Hey everybody, I hope you're all doing well. Today we're going to be talking about continuing on with the fifth tab, solving trig equations. So if you want to open up to that, and again, if you don't have your flip notes, that's fine, not a big deal. But what we're going to talk about, we're going to add on, we're going to do a new strategy. So the strategy that we're going to talk about today is factoring. In the methods of factoring, we're going to use a GCF or like an unfoil idea. The one thing you have to remember whenever you're solving by factoring, you have to always check for extraneous solutions. And remember what an extraneous solution is one that you got by doing everything right. Everything sort of makes sense. It should work, but for some reason it just isn't. And you check that, and I'll show you an example. You check that just by plugging it back into the original equation and seeing what happens. So what we're going to do, two examples down below, one for GCF and one for unfoil. Remember, at any point in time, pause and rewind if we're going too fast. That's the beauty of having these all in a video. So the first one we're going to look at is example 3. So example 3 is an example of factoring with a GCF. So the equation that we're going to solve is sine of x is equal to sine of x times cosine of x. Now remember, anytime that you're factoring, your whole goal is to kind of use that zero product property. So in order to do that, we want to have a 0 on one side. So my first step is going to be subtract sine from both sides. And remember, you can do that by things that we talked about up here. You can we know this is an equation. We talked about right here, getting all the terms on one side. You can do that. You couldn't do that with identities like when we were proving them because we didn't know if that equation sign was true. Now that we're solving, we know the equation sign is true. So you can do all the things that, like moving things back and forth. So we've got 0 is equal to sine of x times cosine of x minus sine of x. Then hopefully you can see that the GCF that I'm going to factor out is sine of x, which leaves me with cosine of x minus 1. So what I'm going to do is use the zero product property. Remember, what that means is taking each of these smaller pieces, now that it's like a multiplication problem, and setting them each equal to 0. So it would be sine of x is equal to 0 and cosine of x minus 1 is equal to 0, but I can kind of just skip ahead and say that would be where cosine is equal to 1. So what you're going to do is you're going to go and look at your unit circle. Sine of x means that where is y equal to 0? Y is equal to 0 at 0 and then again at pi. And if you need to flip over and use your unit circle for that, that's fine. Cosine of x, we're looking for where x, because that's what cosine is. So on the unit circle, where is your x value equal to 1? And that's happening at 0. You might notice that we got a repeated solution of 0. That's fine. That doesn't really matter much. It just gives us one thing less to check. Because what we're going to do now is check to see if any of these are extraneous. So what I'm going to do is I'm going to just do this on a separate sheet of paper because for me that's just easier. I'm kind of running out of room on there. So I'm going to flip it over and use my unit circle. So for that problem right there, the solutions that we just got that I want to check, we got that x is equal to 0, pi, and then again 0. I don't need to check 0 twice, so I don't really even need to worry about that. But go back to the original equation. The original equation was sine of x equals sine of x times cosine of x. So what we're going to do is we're going to plug each of these values in for x. So first I'm going to plug a 0 in for x. So it would be sine of 0 is equal to sine of 0 times cosine of 0. Remember 0, that means the angle 0, which is right here. So if I'm trying to find sine of 0, sine is the y value. So it would just be 0 is equal to, again, sine of 0 is the y value times the x value. So 0 equal to 0? Yes. Then we're going to do the same thing for pi. I'm going to plug pi in for all your x's. So it would be sine of pi is equal to sine of pi times cosine of pi. So I'm going to go over to the angle measure of pi. Sine of pi is the y value there, so it's 0 is equal to Again, sine of pi is the y coordinate times cosine of pi, which is the x coordinate. So now is 0 equal to 0? Yes. So both of these worked out, and as it turns out, we don't have any extraneous solutions for this one. They all worked. Let's go flip it over again. We're going to look now at example 4. Example 4 is going to be an example of factoring by unfoiling. And that just means like the quadratic, the double parentheses. We factored this way a lot in Algebra 2, even a lot in our class. So the problem that we're going to try to solve here is 2 secant x minus secant squared x plus 2 is equal to 3. So remember, when you're factoring, you always need to have 0 on one side. So I'm gonna, I like my squared term to be positive, so for that reason, I'm gonna move everything over to the right. So if you need to show this in more than one step, that's fine, but I'm going to go ahead and move secant squared over there, subtract away 2 secant, and subtract 2. And now I'm just left factoring this sort of like a quadratic with a double parentheses. So that gives me secant minus 1 and another secant minus 1. As it turns out, this is it just is one that factors into the same thing. That's fine. Basically, we were looking for the two numbers that multiply to get 1 and add to get -2. So either way, we factored it into the double parentheses. So now we're going to use the zero product property again that has secant x minus 1 is equal to 0. We have that twice, but we don't need to write it down. So what we're trying to do here is find where secant is equal to 1. Secant is the reciprocal of cosine. So what this really means is I'm looking for where cosine is 1 over that. So 1 over 1. So it actually just happens to be the same thing. So what we're going to do is look on the unit circle and say, where is cosine? Where do you have an x coordinate equal to 1? And that happens at the angle measure of 0. So again, what we're going to do, I'm going to show you on a separate sheet of paper how we would use the unit circle to go ahead and check that work. So the solution that we got for example, what is that, example 4, is that x is equal to 0. So what I'm going to do is I'm going to take the equation. It was secant, it was 2. I'm going to go right to that top line. Secant x minus secant squared x plus 2 is equal to 3. So now you know that x, the angle measure, is 0. So it'll be 2 secant 0 minus secant of 0 squared plus 2 is equal to 3. So 0 is the angle measure, so that means I'm looking at these coordinates here. So secant of 0 is the reciprocal of cosine, so it's 1 over 1. So it's 2 times 1 over 1, which is just 1, minus secant of 0, which we know is just 1. 2 times 1 is 2, minus 1 squared. 2 minus 1 is 1 plus 2, 3 equals 3. So that one, it looks good. So you always want to check anytime you're using a factoring method, you always want to check for extraneous solutions. All that means is that you're plugging in your answer back into the original and seeing if both sides balance out. There is an example, on the Schoology assignment, you will get some extraneous solutions, so just make sure that you're checking. Again, I'm going to give you a couple of try these problems. So I want you to first do the try these problems before you go ahead and move on to the questions that I've posted on Schoology. You can see in this one, this looks to me like a factoring with the GCF. Make sure you get everything to one side. you get an answer of 3 pi over 2, but it ends up being extraneous. So this is an example right here. You're going to see what it looks like to get an answer, but you should see when you plug that back in, your left and right side should not balance out. So this really means no solution for this one. The other ones are a little bit more straightforward. So just, work those out and make sure that you're doing these, letting me know if you have any questions before you go ahead and move on to the Schoology questions. So I hope you all are doing well, and we'll see you again soon.